Okay, this is MTB 1106, Chapter 3, Section 2, Part 1. This deals with truth tables for negation, conjunction, and disjunction. Make sure you understand that negation is when you change a statement from its original to its opposite, so to speak. Is to is not to is. Conjunction is and disjunction is or. It says, consider the following statement. Yogurt contains probiotics and whole wheat bread contains antioxidants. Under what conditions can the statement be considered true? Under what conditions can the statement be considered false? In this section, we will introduce a tool used to help us analyze such statements. We often encounter statements that include words not, and or. These statements are called negations, conjunctions, and disjunctions, respectively. So, again, negation is a not, conjunctions an and disjunction or. Understanding which such statements are true and when they are false can affect our daily lives. Making informed decisions when encountering these statements can have long-term effects in many aspects of our future. Okay, so what happens here is that if we look at this, it says a truth table is a device used to determine when compound statement is true or false. 5 basic truth tables are used in constructing other truth tables. So you've got to know these 5 basic truth tables and how they are written. 3 are discussed in this section, tables 3.2, 3.4, and 3.5. In other words, we're going to negation and then conjunction and disjunction. And 2 are discussed in the next section, section 3. So section 3.5 uses truth tables in determining whether a logical argument is valid or invalid. All right, so negation, which again is not, and so the first truth table is for negation. If P is true, a true statement, then the negation of P is not P, is a false statement. If P is a false statement, then not P is a true statement. So here's how it works. So if the original P statement is true, then the negation of P, which is the opposite, is false. If the original P is false, then the negation of P is true. On our conjunctions, if a compound statement consists of 2 simple statements, P and Q, there are 4 possible cases. 4 possible cases are, case 1, where P is true and Q is true, where P is true but Q is false, where P is false but Q is true, and where they're both false. When we talk about this, here's what happens. So in a conjunction with an and remember the and is the upside down V, okay, says when both statements are true, then the conjunction P and Q is true. When P is true but Q is false, then P and Q, the whole thing is false. Because you can't have a true statement go into a false statement. When the first one is false but the second one is true, it's false. And when both are false, they're false. So you only have one condition on a conjunction where the statement is true, and that's if P and Q are true. When we talk about a disjunction, we're talking about or. Okay. So consider the job description in the margin that describes two job requirements. Who qualifies for the job? So the job description says, municipal program for the redevelopment seeks on-site technicians. The applicant must have a 2-year college degree in civil technology or 5 years of related experience. So when we come back here, it says to help analyze the statement, translate it into symbolic form. Let P be a requirement for the job is a 2-year college degree in civil technology, and Q be a requirement for the job is 5 years of related experience. The statement in symbolic form is P, right side, V, Q, or for the two simple statements. The truth table looks like this. So it's actually the opposite of what you have for and. So if it's true, true, then the whole thing's true. If it's true, false, the whole thing's true. If it's false, true, the whole thing's true. But if it's both false, it's false. Because or can take either one. As long as one is true, the whole thing is true. When you talk about a conjunction, they both have to be true in order for the whole thing to be true. So it says a disjunction, PVQ, is true when either P is true, Q is true, or both P and Q are true. Okay? So on page 105, it sums all this up. Negation, remember it has the little wiggly line in front, is red, not P. If P is true, then negated P is false. If P is false, then negated P is true. Conjunction is P upside down VQ is red. P and Q is true only when both are true. Disjunction, which is P VQ, which is red or, and P or Q is true when either P is true or Q is true or both P and Q are true. In other words, when P or Q is false only when both P and Q are false. So here we have an example problem. And in this example problem, it says construct a truth table with P or negated Q. So we first start out with PQ, which is the table that we worked with before, and we already have these over here with that truth table. Here's that truth table here. We then go to figuring out P, so we write P here. And this is just transforming this part of P over here. We then transform Q over here. And now what happens is we come down here to write what's in the middle. So what's happened is when either one, remember, this is or. So if either one is true, then the whole thing is true. Okay, here we have this is false, here this is true, this is false. And so what happens here is in terms of this, if we have a true, and just remember that when you have a true P and you have a negated Q, then that means it's false. Okay? If you have a true P and you have a negated false, that means it's true. So true, false ends up being here. So this is an and. I'm sorry, this is an and. There you have false, false. So this is false. This is a negated false, which means it's true. And then here, you have a false true, which gives you a false. And so that's where we get this false here, true here, false here, false here. Okay? So what they're doing is they're showing you that, okay, and I don't think I explained that very well. So here's the negation. True, false, or here's the Q. So this right here is just nothing more than writing this again. So then what happens if we go do the negation, if this is true, negated is false. If this is false, negated is true. If this is true, negated is false. If this is false, negated is true. Now we're looking at these two. And so in terms of this, with an and, remember they both have to be true in order to be true. The negation has to be true. So this is true and false, which makes the thing false. This is true and true, which makes it true. This is false and false, which makes it false. This is false and true, which makes it false. Remember, that upside down V is and.